I think once we are not really getting any topic, so we will go as we have planned. And
Yeah, sure.
yeah, so
So,
just a small introduction about our guest speaker. Vansh Kaul is an expert at Codeforces. He's rated 4 star at Codechef, and also he's in final year undergraduate at Pune Institute of Technology. Thank you so much, Vansh, for joining us, and you can continue. Over to you, Vansh.
yeah, thank you for having me. So let's start. How many of you know about number theory? Just you can type in chat if you are familiar with number theory, as in prime numbers, primality test, and those things. You can just write yes or no. If you are familiar with that, you can type yes, otherwise no.
Actually, see, we already have sessions with people where we solve prime numbers and reversal number, these kind of problems. So I'm sure many people already have these kind of ideas.
Yeah, but I wanted this session to be a little interactive so that I can know how much they are learning and what's the
Yeah,
matter. Yeah,
sure, sure. I will encourage people to just type in the chat
yeah,
box if you're feeling uncomfortable with the mic or something. Please do type.
yeah, sure. Anything will do. Yeah, you can just type yes or no. Just that. Because if you are familiar with some topic, then we can move to some other topic. And if you are not familiar, so we can teach you something from that domain. Yeah, so no responses till now. Yeah, so Vaishnavi, um, which year you are in
I'm
right
in
now?
third year. Third year.
Oh, okay, you are in third year, so you must be knowing about prime numbers and primality test, yeah?
Yes, yes.
Yeah. So should I go ahead with that, or should I just take some other topic?
So see, actually we have already done prime number and reverse number, these kind of problems. So like yeah, you can go ahead with number
Like,
theory.
yeah, I can go there. So I'll go ahead with number theory.
Yeah.
So, as in, if I give you a number, say n, yeah. So, how will you check whether the number is prime or not? So, what is the best method that you can go ahead with it with? Can somebody tell, as in unmute themselves and just tell what you think of is the best way to check if a number is prime or not? Shivang, can you tell? Okay.
Hello.
Yeah, Shivang. Can you tell if given a number
Well,
n, if the number is prime or not? So how will you tell that if a number is prime or not?
okay, so you want the efficient method, right?
Yeah, the best you can come up with.
Hello.
Yeah, the best you can come up with. The best method.
Okay, so what we can do is to we can pre-compute some numbers. Like we
Yeah.
can use CU to
Okay.
pre-compute some number, and and then we can check for every test case. We can check if number is prime or not in. So like
Yeah.
computing in and login.
Yeah. Yeah. So thank you, Shivang.
So
Yeah. Okay, so Anika says running loop till square root of that number. Yeah, so it really depends upon the nature of the problem. Say if I give you only one number, so wait, let me share my screen. Okay. Uh, can you share? Can you see my screen?
Yes, yes, Vansh.
Yeah. So let's say that we have some number n. Okay. Uh, and I want to calculate if sorry, I want to check if n is prime or not. Okay. So the first method that comes to our mind is, let's say we check for every number from 2 to n minus 1 if it is divisible by any number or not. Yeah. So all the numbers from 2 to n minus 1, we check if n is divisible by them or not. And if n is divisible by some number in that range, then we say that the number n is not prime. And if none of the numbers divide n, then we say that n is prime. Okay. So that's the first method that comes to our mind when we say that we want to check if a number is prime or not. Yeah. So now we want some efficient method. Yeah. So what we can do here is um, we can just I don't want to check till n minus 1. So can somebody give me some other option that yeah, we don't have to check till n minus 1, we can check till this number and we can be sure if the number is prime or not. Just some number, say n minus 2 or n minus 3. Any number that we can check and we can be sure of that the number is prime or not. Anyone in the chat? Yeah, so Parth says square root of n. So the basic intuition says that we can just, for example, let us take a number, say 12. Yeah. So what are the divisors of 12? Say we know that the prime numbers has only two divisors, one and the number itself. So for 12, we have divisors 1, 2, 3, 4, 5. No, sorry, 5 is not there. 6 and then 12. Yeah. So we can be sure that say, see, 2 multiplied by 6 will give us 12. So we can be sure of that no number greater than n by 2 will ever divide n. I hope you get this point. You can just type yes or no. The people who know about square root n, uh, other than that, if you people get this intuition that n by 2 will be the right choice, yes or no? Yeah. Yeah. So n by 2 will be a choice. So no number greater than n by 2 will be a factor of the number n, or will divide the number n. Yeah. So but so here we have to check n by 2 numbers. Yeah. So the problem here lies within the fact that we have to check a lot of numbers. So and there is a method that we can reduce this. So Parth was saying that the number should be square root of n. Yeah. So Parth, can you tell why square root of n? As in, why there can't be any number greater than square root of n that we that we'll have to check? As in, say 6 is greater than, I'm sure 6 is greater than square root of 12. Square root of 12 is around 3 point something. So 4 and 6 both are greater than the square root of 12. So you are saying that we do not have to check for any number that is greater than square root of n. Why is that? Can anybody tell? Vaishnavi? Yeah, Shivang. Shivang, you want to say something?
Okay.
Shivang, yeah,
So let's say you have like two numbers.
yeah,
You can say a into b is equal to n. Like we want to find if n has there are two numbers that divides it. So we'll say a
yeah,
into b equal to n.
yeah. So
Right.
a into b equal to
So
n. Yeah. So
so
there are
what we
two
will do
numbers
is
a and b which multiply to n. Yeah. Okay.
so let's say a is greater than square root of n.
Yeah. Okay. If a is greater than square root of n.
So then okay. So then if if again b will be greater than square root of n, then it will be greater than n. So that
Yeah. So the
so b
product will be
has
greater
to
than n.
yeah. So the b has to be less than square root of n.
Yeah.
So either so 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 instead of checking for a, we'll check for b because it should be less than
Yeah. Yeah.
root n.
That that makes sense. Yeah. Okay. Thank you, Shivang. Um, yeah. So what Shivang tries to say that see, you can also check in the prime factorization of 12 that we have numbers 1, 2, 3, 4, 6, 12. See the factor, sorry, it's not the prime factorization, it's the factorization only. So, my bad. So, here the factors are in pairs. So, 1 and 12, then 2 and 6, then 3 and 4. So if we make a line here, so all of these numbers have some number after this line that corresponds to the previous number. So 1 corresponds to 12, yeah, 2 corresponds to 6, and 3 corresponds to 4. So 1 into 12, 2 into 6, and 3 into 4 makes 12. So what Shivang was trying to say that say there is a number 6 which is greater than square root of n, but there will be a counterpart, say 2, which will be less than square root of n. This will only not be the case when the number is a perfect square. Say the number 9, which has a factorization of 1, 3, and 9. So we cannot make a line basically because 3 is actually the perfect square root of 9. So 3 into 3 will be 9 only. So we have to check till the number that is the square root of the number. And we can be sure of the fact that if there is some number after this line, it will correspond to a number before this line. Yeah. So we can make a line right here. Okay. So 9 is after this line, so 9 corresponds to 1 before this line. So we can be sure of the fact that there will be a number less than square root of n that will divide n if n is not a prime number. If that makes sense, you can just type yes in or in the chat, or if you have any doubt you can just ask that. Yeah, any questions or doubt are welcome at any time. Okay. Yeah. So uh, so now what will be the complexity of this method? The complexity of this method will be obviously O of square root n, because we are just checking n numbers and we are checking if they are divisible by the number n or not. Yeah. So the complexity of this method will be square root of n. Yeah. So can we do better than this? Can we check if a number is prime or not in less than square root of n time? So here comes the method that Shivang was telling in the beginning itself, that if say we are given some q numbers, and for all of those numbers, uh, say n1, n2 up to nq, we want to check if we want to check for all of these numbers that if the number is a prime number or not. Yeah. So we will be taking time, say under root n1 for this, under root n2 for this, under root n3 for this, and under root nq for this. So our total time complexity will be q into root n. So can we do some pre-computation and reduce this time complexity to some better value? That's the question now. If anybody has some method that they can just tell. Are you guys shy to tell, or are you guys not interested in that? I can teach something more interesting if you are not really interested in this.
I think, Vansh, can you repeat just one more time the question which you asked?
Yeah, I have asked the problem that you have given q numbers.
Yes.
Okay, so the numbers are say n1, n2, n3 up to nq. Yeah, you have q
Yes.
numbers, any random q numbers, and so the method that I showed just now will give us the complexity of q into root n. Yeah, because for every number we will have a complexity of root n, and we have q numbers, so the complexity will be q into root n. Yeah, so this will be the complexity. So do you get that the complexity will be q into root n?
Yes, I think everyone got that.
Yeah, so I am asking if there is a better method to it, as in do some pre-computations or compute something prior to this, and then come up and say, yeah, ask me any number, and I'll answer that quick enough, that if it is prime or not. That's my question. I think now that's clear.
Yes, yes, it is.
Yeah. So as you told that some you people have been taught about prime numbers and number theory. So anybody has any method that they want to share, or just if you don't know the method, that then it's okay. You can just throw your intuitions, as in what do you think should be the method. See, I'm asking you guys this because the method that I'm going to teach is is there in funnily enough, it is there in I think seventh or eighth sixth class NCERT. So you guys have been taught about this in like sixth class.
Actually, once we have majority of people who are from first year, so I don't think so. They are. We have just done the basics where just we divide by like we take percent I, and if it we take the corner cases, and I think that was the basic method. I think everyone knows.
Yeah, yeah. The method I'm telling about is they are in sixth class NCERT. So all of them are above that, no? Yeah. So it is in sixth class NCERT. The method is called sieve of Erasmus. Have anybody of you heard about this sieve of Erasmus? Just yes or no will work. Okay. No. No. Okay. So we'll start with the basic definition of prime number, then and we'll then build upon it. Okay. So Vaishnavi, could you just tell me that what is a prime number basically?
Prime number is something that it is divisible by itself, like one or the number which is divisible by itself.
Yeah. So if I have a number, say something like X number, okay, and I choose a multiple of X, and X is not one basically. Yeah. So I choose a multiple of X. Can you be sure of the fact that it will not be a prime number? That multiple of X will not be a prime number. And multiple, and by multiple I mean not into one, into two, or into three, or into some K. Yes. Did you understand what I just said?
Can you repeat once again? Like, if you are saying how we will check if the number is prime or
No,
if the number is
no.
prime.
I'm just saying that
Hmm.
if you have some number X which is greater than one,
Hmm.
and I ask you to multiply this number with some other number which is greater than one, the
Yes.
product that you will get, can you be sure that the product will be a non-prime number? It will be a composite number. Parth says yes. What about you, Vaishnavi?
Hello.
Yeah, Vaishnavi. Yeah,
Hello.
yeah.
Yeah. Actually, once I'm facing some internet issues, so I didn't really hear you. You're saying ki if we multiply two numbers. Hello.
Which are both greater than one. So can you be sure of the fact that the product will be a non-prime number or a composite number?
Yes.
Yes. Yeah. Obviously.
Yeah.
Yeah. So this is the thing that we'll be working on. Okay. So I am giving you some numbers which I'm sure of are less than some k value, okay, or some n value. Say I'm giving you 10 numbers which are less than 100, okay. So and I'm asking you randomly this number is prime or not. So for that we'll have to do some pre-computations, okay. So let's say abhi hum n 20 tak lete hain. So we start from 1 2 3 4 5. अभी 20 तक छोड़ो, 10 तक लेते हैं बिकॉज थोड़ा सा ज्यादा रिडंडेंट हो जाएगा, ठीक है. तो हाँ, तो वी स्टार्ट फ्रॉम टू. सो दिस इज अ रियली बेसिक मेथड, ठीक है. विल स्टार्ट, वी नो दैट वन इज नीदर प्राइम नॉर कंपोजिट, सो विल be leaving one aside and we'll be starting from 2, okay. So if I'm starting from 2, so let me encircle 2, okay, and all the multiples of 2 I'm sure of will not be prime, so I'll cross out all the numbers which are a multiple of 2. Yeah. So I know 4, 6, 8 and 10 are multiples of 2. So I'll just be crossing out those numbers. Okay? And now the next number is 3. So I'll be encircling 3, and I'll be crossing out all the multiples of 3. So I know 6 is a multiple, it is already crossed out. Then 9 is a multiple of 3, it will be crossed out right now. Yeah, so like this, that. So now 4 is already crossed out, so we'll not be going to that. Now 5 will be encircling. Okay, and the multiple of 5 is 10, so that is crossed out. 7 will be encircling. So from till 10 we have some numbers crossed out, and we have some numbers encircled. And so this looks like a sieve. Yeah, sieve matlab chhanni basically. So this looks like a sieve that at some places there is a cross, and at some places there is a circle. Yeah, so that's why this method is called sieve of Erasmus. So Erasmus was the name of the person who developed that. Yeah, so sieve of Erasmus. So the numbers that you see as encircled are basically the prime numbers till that number that we are checking. Yeah. So for example, if we are checking till say 15, so 12, 13, 14, 15. Yeah, so for 2, 10, 12 will be crossed out, then 14 will be crossed out. Then for 3, 15 will also be crossed out, and 12 is already crossed out. So then 11 will be encircled, and so will be 13. Yeah. So if we check till 15, these are the prime numbers. So did you guys get the method that I taught right now? Just yes or no? We'll be discussing about that further, but the things that I just told till now, are that clear? Yeah. So these numbers basically will be prime numbers, and this is a really basic method that you just go to a number. If it is already crossed out, then leave it, and if it is not crossed out, then encircle it, and just cross out all its multiples. Just do that, and you will be fine. You will be ready to go. Yeah. So I am now saying that you have to go to a number to cross its multiples out. Yeah. Now the question that lies here is, till what number we'll have to go. Say we had numbers till 15 here. So till what number I had to go uh, so that all the composite numbers till 15 will be crossed out. See, I start from 2, then I go to 3, then I go to 4, 4 is crossed out, then I go to 5. So till what number I have to go to make sure that all the numbers that are not prime are crossed out. The answer lies within the fact that the the method I just taught before this, the square root n method. So just type it in the chat till what number I have to go. Or if I'm not clear, just tell that I didn't understand this part. I'll be explaining that. Till the square root of the number. Yeah, great. Yeah, so we'll be going to the square root of that number. Why? Why will we be going to the square root of that number? So for to prove that, basically, so that's an intuition that we'll be going to the square root of the number. But actually, to prove that, let us see. Okay, so when we are starting with 2 and we're crossing out its multiples. Yeah, so we cross out 4, then we cross out 6, then 8, then 10, then 12. Yeah, so we start from 4. We start crossing out from 4. Now when say we have 3, so for 3 we'll start crossing out at 6, because 3 into 2 is 6. But the thing is, that 3 into 2 will be same as 2 into 3. So the value 6 will be crossed out already, because it was crossed out when we were crossing out the multiples of 2. So any number less than 3, that multiples will be crossed out already. Okay. So we start from 3 into 3, because all the numbers before 3 will be already crossed out. So we'll be starting from the number 9. We don't have to check 6 only. We just start with 9. Okay. We start with 9, then we cross out 12, then we cross out 15. Now when we go to 5, we will be crossing out 10 and then 15, because 10 is equal to 5 into 2 and 15 is equal to 5 into 3. But the thing is that 10 is equal to 2 into 5 and 15 is equal to 3 into 5. So when we are crossing out the multiples of 2 and 3, so the 10 and 15 are already crossed out. Yeah. So now we can start directly from 25. And as we know that 25 is not in our range, so we don't care about the numbers greater than 25. So we can just stop right here at 4. We do not need to check after 5. Yeah. So for say 2, we'll cross out 4, 6, 8, 10. So the numbers I'll just, yeah. So 4 is crossed out for 2, and then 6 is crossed out, then 8 is crossed out, then 10 is crossed out, 12 is crossed out, so is 14. Yeah. Now when we go to 3, now we will start from 9. As I told, we'll be starting from the square of that number, because all of the multiples before that have been already crossed out. So 9 is crossed out. Now 3 into 3 is 9, then 4 is 12. 12 is already been crossed out, and then 15. Yeah, 15 will be now crossed. Now be crossed out. So 4 we don't have to do anything, and we can stop right here. And you can just see that if we went till 4 only, we didn't have to go to 15. If we went till 4 only, all the numbers that are composite have been already crossed out. Let's say 6, 8, 9, 10, 12, 14, 15. All of them are crossed out, and we are left with only the numbers 2, 3, 5, 7, 11, and 13. So this is the basic theory about this. Now, if I ask you, say, is number 8 prime? You can just say no, it's not, because it has been crossed out. If I just ask you 11, you will say yeah, it's prime, because it is not crossed out. It's encircled. Yeah. So we just know now that which number is prime or not. We don't have to check anything at all. So this was the method that I was talking to you about, and this has a beautiful complexity of n into log of n. I'll leave it up to you to check why is that, because this will be a little bit out of today's topics, today's syllabus. So the complexity here is n into log n. So why is that? You will have to check out. And if you have any doubts, you can then message me on LinkedIn or something. So I'll clear that. Okay. Once you check why this is like that. Yeah. Why it is like that. Yeah. So now, this method, I think now it's clear to you guys. Yes or no? If it's not, then we can just, if the method is clear to you, then we can code it out. But just I'm I basically believe in understanding the algorithm first and then coding that. So if it is not clear to you, then we'll be spending some more time explaining this, and then we'll go to coding. So yeah, a yes or no will work. Or if you have any doubt, you can just type that in chat. Vaishnavi, can you just unmute for a second?
Yes, yes.
Yeah, so the other people, are they not interested, or what's the thing with them? Or they want some other topic, or because see, coding I'll not be able to teach if I'm not getting any response. That I'll be teaching, but that will be of no use if people are not getting things.
Yes, yes. I will request everyone, even if a little bit of logic is not understandable, please, he can repeat once again. So,
Yeah, I can
guys,
repeat anything. Yeah, but or I can change the topic even if anybody needs that, or if anybody wants to shift to some easier or difficult topic. We can do that also. If you want to learn basics about arrays, we can do that also. Or if you want to learn segment trees and DP, as in advanced DP optimizations, we can do that also. So anything will work. Just you guys have to be a little more uh, yeah, enthusiastic, I would say. Yeah, if you guys are shy, you can just print your as in type your queries in the chat box. I'll be answering to those. But the thing is, I'm not getting if you guys are understanding what I'm teaching or not. So I'm a little bit, to be honest, I'm a little bit uncomfortable because I'm not getting if anybody is learning something or not. Yeah, so let's start coding this thing. So can anybody tell me the thing that I just did here? What will be the data structure that will be most appropriate to implement something like this? Anybody in the chat? Q. But why Q? Can if you can just type why Q? Okay, an array. See, no answer is wrong. Just you just explain why you think that Q will be appropriate here. As in, what property of Q made you think that Q will be appropriate here? Just type that. Or what made you think that array would be appropriate here? See, you for using every data structure, there needs to be a solid reason that why we are using the data structure. Okay, since we'll be going through numbers one by one, yeah, we are using a linear search. Okay, yeah, but actually we are not using a linear search. We know that these are the numbers there, and we are just crossing or encircling them. So yeah, so linear search, I don't think that we are doing here. Yeah, so we'll be going through numbers one by one. Yeah, but we can do that in any data structure. Like we can do that in stack. We can do that in an array. We can do that in a vector. We can do that in any data structure out there. So so the answer I was looking for is a Boolean array basically. So why a Boolean array? Because see, we can represent the encircles and the crosses by zeros and ones basically. So say ones are the encircled things and zeros are the arrays. I'm sorry. Uh, Crosses are the zeros, and circle things are the ones. So we can do that using a simple Boolean array. And the thing that makes me think that Boolean array will be suitable for this kind of an implementation is that every element in a Boolean array is accessible in O of 1. That for example, say I want to know if what is the fifth element in an array. So I'll be saying that yeah, so fifth element is this, and will be getting that in O of 1, as in we'll be getting that instantly. We don't have to go through, okay, zero, what is the zeroth number, first number, second number, third number, fourth number, and then we get till fifth number. So that thing we have to do in linked list, or we have to do in queue, or we have to do in a stack, that we can only access the top element instantly. All the other elements we have to go through the entire thing to get to that element. But array is a data structure where we can just straight away pick that thing and check what is the value there. So that's why I'll be using an array. And why a Boolean array? Because the things that I'm telling, that and circles and crosses, that can be represented by zeros and ones there. Yeah, so I'll be using a Boolean array there. Okay. So the Boolean array, basically I'll be initializing with ones. Okay. So let's take some number, say we have numbers in n is equal to say 10 raised to power 5. So you can also write this as 1e5 if you guys know that. So that's some trivia for you. So we can write 10 raised to power 5 as 1e5 in C++ basically. Yeah. So and then what we can do is we can just create an array, Boolean array, prime of size n, um, and the basically the number, so prime I um, represents that the number is prime. Okay. Or not. So 0 is equal to, so 0 means composite, and 1 means prime. So at first we'll be setting all the numbers to 1 for just implementation reasons, no other thing like that. Just for 1 to, as in 1 is not basically there. So 2 to n, we'll be setting all the numbers to 1. Anybody knows if there is a function, or if there is a function that does this for us, setting all the values to some value, setting all the values in an array to some value? Yeah, memset. Great. So we can be using memset also. I thought some people will not be knowing about this, so I just used a for loop here. So now we have all of the numbers as 1. So the thing that I was telling, that for what we will be doing is for say we do that till 1e4 now. Yeah. So for int I is equal to 2, I into I less than n, and I plus plus less than equal to n. As I told you that we have to check, sorry, we have to check all the numbers. if they are prime or not. Yeah, so we have to check, we have to run the thing till root n only, as somebody told in the chat also. So now what was the second thing that I told, that if the number is already crossed, then we don't have to care about that. So if prime I equal to 1, if it is prime right now, then what we will be doing is, for int j equals I into I, we'll be starting from the square of that number that we are at right now, and we'll be going all the way till n, and j plus equal to I, because we'll be doing this for all its multiples, so we'll be incrementing it by I. So prime j is equal to 0, as in it's false. So we can do that true or false also. uh, Anything would work. Okay, false. So now this array is created. Now I can check for any number instantly. Say I want to check. So let's do one thing. Let's print all the prime numbers from say 2 to 10. Okay. So for int I equals 2 and I less than equal 100, I plus plus, and if prime I equal true, cout I. So if it is prime, so we will print that number. So let's check if this works. Okay. Yeah. So we can see that all the prime numbers are printed only. No composite number is printed. And why did we start from 2? Because we know that 1 is neither prime nor composite, so we are starting from 2. And all the prime numbers are here. So if anybody has any doubt in what I just did or what I just explained, you can just ask your doubts. So what I was telling you, that if I give you say k numbers and tell if it is prime or not, so you can just say take any k numbers, like for example you take an array and you can just print if it is prime or not. Say if I just remove this, and if I do if I make an array A of 5 elements, any random 5 elements, 15, 13, 87, 34, and 23, or then 100. Yeah, so it's 6 elements. So, and if I check for all the numbers, it will give me the result instantly. I less than 6 and I plus plus. So I will not have to check anything for or what we'll do is we'll size is equal to size of A upon size of A0, and we can do this till size, and we can just print if the number is prime or not. Say if prime AI, if the ith number in the array is prime, cout prime, else cout not prime. Yeah, so the numbers 15 is not prime, so we get not prime. 13 is a prime number, so we get prime. 87 is not a prime number, we get not prime. 34 is not a prime number. 23 is a prime number, as you can see, so we get prime. And 100 is not a prime number, so we get not prime. So this is we just checked in the array once, and we did nothing else. We did not use a for loop here to check if it is a prime number or not. Nothing like that. We just did this, and we get that. And so this was the method that I was talking about. Okay. So did all of you get this? That what I just taught. Yes or no would work, or if any doubt, you can just type that doubt in the chat. Okay. Yeah. So this is the basic code for sieve. So you can so uh, I'll just paste that code in the chat. So if anybody needs this, they can just copy this. Yeah. So this method is basically called the sieve of Erasmus. Now I would like to ask you people one simple thing. Yeah. If you got this, then I would ask you. Otherwise, there is no point asking that. So the thing is, tell me one. Tell me some limitation of this method. We all know that this method is better than the root n method, because there we have to do, say, q into root n computations, and here we are doing n log n computations, which is far less than that, and we are giving the answer in O of 1, like as in instantly. But there are some limitations to this method. So rather than this method, we should be doing root n method in some cases. So what are those cases, if somebody could just tell in the chat, or if whatever way you want to. I think the whole code cannot be copied. It is a little big. So the code got omitted. Yeah. So you can go get the code from the link in the chat. Yeah. So anybody can just tell me that what are the shortcomings of this method, or what are the cases where this method is will not be feasible. Okay, memory, great. Memory would be one limitation. So as in, you want to say, Anika, you want to say that if say we want to we want the we want a to check a large number, say 10 raised to power 9, if that is prime or not. So we cannot create that big an array. Yeah, so we cannot create that big an array to check if the number is prime or not. So for 10 raised power 9, we can do root n operations and we can just get the number, and we cannot do this thing for large numbers. Yeah. So there is a method called segmented CU for that, but it is like a bit out of syllabus for this session. So another thing is that if the number of queries are small, that if I give you less number of queries, so it will be better if you just did say the numbers are till say 10 raised to power 5 and I ask you and I ask you five numbers. Tell me if those numbers are prime or not. So you can just do that in 5 into root n, and that would be beneficial because that way you will have to do less number of computations, but here you will have to do n into log n something like that computations. So that will be better. So if the number of queries is large, if I ask you a large number of numbers to check if they're prime or not, then it is better to go with the sieve method. Otherwise, you can just go with the root n method also. Yeah. So that's the thing. That's another thing. So those are the two topics. So I'll be moving forward. If I want all of you to solve one problem, uh, given say we have two containers and we have in one container, say we have 3 liters uh, of this 3 liters worth of volume, and another has 5 liters, and I want you to come I want you to give me say 1 liter of water. So how can you compute if 1 liter of water can be, or else tell me if it is possible to measure 1 liter of water using two containers of 3 liters and 5 liters respectively. You can have as many as containers of 5 liter and 3 liter as you want. I just want to know that if it is possible or not. If one container is 5 liter and the other container has 3 liter volume, and I want you to measure 1 liter. Fill the 5 liter can with 3 liter container twice. The leftover water in 3 is 1, which is required. Yeah, that's a smart explanation. So yeah, good. So now I want to uh, make this a little more trickier for you. If one container is X liter and another container is Y liter, I want to know what all measurements I can compute with them. And you have infinite amount of X liter containers and infinite amount of Y liter uh, Y liter ones. So I want to know what are the different amounts of liquid that I can measure through those two containers. So I want a generalized solution basically. Also, we can discuss that, but I want an answer from you guys first. Can take a for loop for um, both up to n and do x plus y. I didn't get this. So let us take a step backward and say we have 5 liter and 3 liter. So what all measurements we can compute using 5 liter and 3 liter containers? Give me all the measurements. All natural numbers. Yeah, that's correct. So why all natural? Because that's really simple. That if we can calculate one, then we can calculate for it for any number, because we can calculate one any number of times and we'll get that many liters of water. Yeah. So now let's change the question a bit. If I have one 4 liter container and one 6 liter container, so now tell me the answer, that how many liters I will be able to collect. 2 to n. Can, okay, any other answer? Any other guess? Parth or Anika? Anika also says 2 to n. I think a bit about it. Okay, if you Parth, do you have any answer? Yeah. So Parth says even numbers. So that's the thing. So Anika and whoever is handling Codechef, yeah. So you cannot measure 3 or 5. There is no method to do that. So now can you guys build up something from that solution and tell me a general solution? If I have one x liter and one y liter, what would be the answer for that? Take your time, take a minute or two figuring that out. So multiples of x minus y. Um, X minus y. Okay. So let's take some, but 5 and 3 maybe फिर तो 2 के multiples आते ना सिर्फ, मतलब if we had multiples of HCF, you mean GCD, yeah, of x in x comma y. Yeah, so that's the correct answer basically. So the multiples of GCD of x and y. See, now we'll see why not other numbers. Okay, so let's say that we have 1 6 liter and 1 4 liter. We can never have something that is even. Sorry, that is not even. That is odd, because 6 - 4 or 6 + 4 or any damn thing that I do, I cannot get to a number that is not even. So that is odd. So I cannot get to a number that is odd doing all these types of computations. Now the thing here to notice is that uh, I think this select and delete should work. Yeah. Yeah. So the thing to notice here is that if say there are two numbers x and y, no matter what we do with these two numbers, no matter what, and we can just do addition and subtraction. X plus y, x minus y minus x, y plus x, anything you want, any number of times. The GCD of the two numbers will be same. For example, x. So you add y in x. So we get x plus y, and y. So the GCD of these two numbers will again be same. Then say you check x minus y and y. The GCD of these two numbers will again be the same. The GCD of these numbers, and these numbers will again be the same. Can anybody tell me why? Can anybody from your side tell me why the GCD of these numbers will be same? The question is, so we have two numbers x and y. So whatever maybe say the GCD of x and y is g. Yeah. So I am telling that x plus y and y's GCD will also be g. The GCD of these two numbers will also be g. Why is that? I think the question is clear now. Yeah. So that's really simple to guess why that will be true. If anybody has any idea, it would be nice of you to share. Yeah, so the thing is that let's say the GCD of wait, the GCD of x and y is g. Okay, so I can write x is equal to some k1g. K1 is some constant, I don't know what, but I can write x as some k1g. Is that correct? And y as some k2g. K2 into g. We are not going till k3g, so we are just stopping at k1g and k2g. Yeah. So is this correct? Yes or no? Can you assure me of the fact that this is correct? Yeah. Yeah. Yes. So if I say x plus y, so what is basically x plus y? Plus y. So x plus y is nothing but k1 plus k2g, sorry, k1 plus k2 into g, k2 into g. Similarly, x minus y is k minus k1 minus k2 into g, k1 minus k2 into g. So if we pair any of these two numbers, we have four numbers, and we pair any of these two numbers, the g part will be common. So that is the basic, that is the common divisor between those two numbers, basically. No, you get that? And if we take any pair amongst those, you get g as the common thing. So g must be divisible by both of them. So that's why G will be the HCF of all the numbers that we get in these cases. So say if we add y to x, not one but two times, so it would be nothing but here we get 2, here we get 2 into k2g, then also it will be g only. If we multiply, if we divide, subtract y from x 4 times, it would be k1 minus 4 k2g, then also it would be g only. So anything, any number of times, if you do any number of operations on two numbers x and y, their GCD will not be changing. So we can make one number equal to 0 and the other number will be GCD. So thus you get the GCD of the two numbers basically. So let's say here we have wait. So let's say here we have two numbers. Let's take 5 and 3 only that we had taken. 5 and 3 only. Remember, I had told you can do anything with these two numbers. So I am subtracting 3 from 5. So the new pair is 2, 3. Now I am subtracting 2 from 3. So I am getting 2, 1. No, now I am subtracting 2 from 1. I am getting 1, 1. Now I am subtracting 1 from 1. I am getting 1, 0. So if this number is 0, so this number will be GCD basically, because now we cannot do anything. No, we cannot do any number of operations now and change the fact that this number is the GCD. No matter how many times you subtract 0 from this again and again, you will not be getting any other number other than 1. And if you add 1 in this number any number of times, you will only be getting a multiple of 1. So basically the GCD will be this number. So this was a method to calculate the GCD of two numbers. And you can also relate it with that problem where we have two numbers x and y, and two containers with volume x and y, and we want to shift something from the other. So now you get that why it will be the multiples of GCD. So you can get GCD from this way, and you can just multiply it any number of times, and you will get any volume of water. So this is a method that we use to calculate the GCD, and it is called as Euclidean GCD method. So what we do generally is say this number is bigger than this number, we just subtract this number from this number, and we get say we reach to another number. Then this number is bigger, so we subtract this from this, we reach to another pair, we subtract this from, and we do this till one number is 0. If one number is 0, the other number will be the GCD of the two numbers that we had started with. And also for all the pairs basically. These two numbers have GCD 1, these two numbers have GCD 1, these two numbers have GCD 1, and all the pairs. So if we want GCD of these two numbers, so here it is 1. Okay, so let's do it for 4 2. It's basic now. 4 2. So it will be 2 2. Subtract bigger from small. Subtract smaller from bigger. Now it will be 0 2 or 2 0, anything. So 1. So this is 0. So this will be the GCD. So 2 is the GCD of 4 and 2. Yeah. So you can do any number of operations and you will get to the answer. Yeah. So now this method is clear, I suppose. Yeah. Just yes or no. Others. Yeah. So this method is clear. Yeah, but this method has a small problem. Now let us see the problem. Yeah. So the problem is, let's say we have a number, say 1,000. Yeah. And another number, say 1. And we have to subtract the bigger number uh, from the smaller number. Sorry, smaller number from the bigger number. So how many operations would we require to reach 0? How many operations would we require to reach 0? 1001. Any other guess? Any other guesses? Okay, 1,000. Anika or the admin. Any word? Any you would want to share? How many number of steps would it take? If I yeah, so the question is the this method I'm doing that is subtracting the smaller number from the bigger number, and I get another pair, then I get another pair, and I want to reach till one number becomes 0. So this method, if I apply to this problem, how many steps would it take me to get the answer? So the answer will be obviously be 1 0. So but how many steps would it take me? That's the question. Yeah, 1,000 steps. Great. So I'm not happy with this method because obviously this method takes a lot. I know that it will be 1 0 only. So why would I care to do these many number of steps just to get a simple answer? So basically, we have a better method for this. So can anybody just tell me a little better method? Just a little change in this method only that will get us the answer for the whole thing in a quicker way. The answer will be the same only, but we'll get that in a quicker way. So I'll give you a simple example. Yeah, I'll give you a simple example. Say we have 7 and 2. Okay, and I am repeatedly doing these types of computations like 7 2, then I have say 5 2. You know what to do, you just subtract the number. Yeah, so 3 2. Yeah, now 1 2. So can I get from here to here, from here to here in just a single step? Like you must already know that where I am about to get just from seeing this thing. I just want a step to get to a number where this number becomes smaller than this number. If we start from this number larger than this number, I want a step this number smaller than this number. So can we get there in a single step? mod. Yeah. So why mod? Because we know that if we where is it? Yeah, if we keep on subtracting this thing by that, so we'll be leaving with the remainder of these two. So if we will be remaining with basically 2 7. So sorry, what did I do? 2 7. We'll be doing the step 3 times, and we'll be subtracting 6 from that, and we'll be remaining with 1. So we know that we'll be remaining with 1. So instead of subtracting, what we'll be doing is we'll be like 7 by 2. So we'll be doing 7 mod 2. Mod is nothing but remainder when 7 is divided by 2. Yeah, 7 mod 2 is nothing but remainder when 7 is divided by 2. So it will be 1. We'll be getting 2. So now 2 divided by 1, remainder is 0. Here 1. So 1 will be the answer, and we get in a lot less number of steps. Say for the example that I previously gave, 1001. So what I'll do, 1000 divided by 1. What is the remainder? 0, and the other number is 1. So we get the answer in one step. That the previous solution was taking us 1000 steps to do that. Yeah. So this is a better method, and the complexity of this method is basically uh, log of minimum of x comma y. So if two numbers are x and y, and we get that in log n steps. So you can imagine how less number of steps that we will require for that. Say if two numbers is say 10 raised to power 9 and 10 raised to power 9, we'll be getting it in at max uh, 28 steps. At max. I am not saying two numbers, these two numbers only. I am saying any two numbers in this range. So 10 raised to power 9 to 28. So we have jumped a lot. So to check the code, what we can do is we can just write the code for GCD. So int GCD, two numbers, say x and y. And one more thing, in each step, the method that I am telling you right now, you will be knowing that obviously anything if is say anything, say a mod b, be it any a, the answer would be obviously less than b, right? The answer will be less than b only, because anything divided by b cannot leave a remainder greater than b. Yeah. So in each step, the order will be reversed. So if 7 2 and 7 is greater than 2, so the next step will be 1 2, and here is 2 is greater than 1. So the order will be reversed in each step. And what is the base condition? If say x is equal to 0, return y, else return GCD of x mod y. So we are dividing x by y, and the other number will be y. So sorry, y here and x mod y here. So if if y is 0, return x. So if this number mods to 0, then this number is the remainder basically, and this number is the value, and in each step it is getting reversed, because say x is greater than y. So now the value will be changing to x mod y and y, but x mod y will be less than y, so y will be the greater number. So let us check if this works. So see out GCD of e comma 5, it should be 1 1. Yeah, correct. So 3,6 will be 3, 3, and 4,6 will be 2, as we discussed earlier. Yeah. So this is the correct code for this. Also, you can use inbuilt function in C++ underscore underscore GCD if you don't have the time to write this. It was just for your understanding that how Euclidean GCD really works. Yeah, so that was it. If you have any doubts or anything that you want to ask, you can just go ahead.
Yes.
Yeah, hey Vaishnavi.
Yeah. I think the problem, the way you explained was very clear. I don't think so. If still anyone have doubt, please type in the chat box. Uh, till the people, if they type in the chat, till the people type in the chat box, can you just tell us like a few questions if you could answer? Like some of them have asked that from where to start practicing or learning coding, like
Yeah,
how the one should start it.
yeah, okay, so the FAQs, right?
Yeah.
Yeah, so from where should you start coding? Like, uh, before that, I want to address one thing that you should start coding. Starting में क्या होता है that basically starting में many of the people don't know the syntax of any one language है C C plus plus. वो ऐसा बोलते हैं कि मतलब C C plus plus पूरा हो जाए या कोई भी लैंग्वेज मतलब साहब पाइथन पूरा हो जाए उसके बाद ये होगा चालू होगा CP या ऐसा कुछ. बट द थिंग इज वो कभी पूरा नहीं होगा, कोई भी लैंग्वेज कभी पूरा नहीं होगा. सो यू जस्ट स्टार्ट सॉल्विंग प्रॉब्लम्स. And from where to start, it can be anywhere. Start from hacker start from hacker rank, start from Codechef, start from Codeforces. Just start with simple problems and you will get the hang of it. I would recommend starting from hacker rank because it has really subtle problems or really simple problems for the beginners. um, yeah, so okay, so I'll get to that, Anika. Yeah, so as far as I remember, the basic problem in the problem solving section in hacker rank is A plus B. Yeah, so you can start from there and you can just increase the difficulty and you can just solve the problems. But make sure the problems that you are solving, whether you are solving them on your own or you are taking any help, make sure that you understand what's going on. Like if you use some algorithm, as in I explained you GCD. So I taught you why you want to learn GCD, because there are some problems that can help that GCD can help you solve. So make sure you are learning and you are understanding the approaches and not just mugging up the solutions. So that would not work, obviously. Yeah, so start from anywhere. I would recommend Hacker Rank, but it's not some hard and fast tool. You can start from anywhere, but the thing is, you should start. Yeah. So Anika, yeah, how many problems should we practice to be more efficient and develop an efficient approach? Yeah. So the problem is a bit. The statement is a bit general. So efficient approach as in it depends on the difficulty of problems that you're solving. As in when I started, I used to solve, if I talk in the terms of Codeforces rating, so I generally used to solve the problems around 800 or 1000 rated on Codeforces, which I'll just show you if the topic is just going on that. I'll take the opportunity to show you. Yeah. So Codeforces, there is a problem set here, and you can put any difficulty. 800, I think 7 or 800 is the lowest difficulty, and you can put 800 to say 1000. and you'll get all the problems in this difficulty range, and you can just go and solve them. Like they're like really basic problems. Okay, so you can just go ahead and solve them, and you will be better with the problem solving, and you can just increase this rating. Now when I solve, I generally solve around 1600 to 1800 rated problems. Yeah, so as you can see, I have solved some of them. So you can just start from a basic level, and take your level forward with every problem that you solve. So, and how many number of problems, it basically depends upon every individual. Like I have some friends that are rated uh, like 1600 or 1800 on CF, and they have solved a lot more problems than the world's best, say the world number one tourist. So I have a friend who has solved more problems than tourist. Tourist is like world number one on Codeforces right now. So it generally depends on the person to person. So yeah, see, top rated tourist. So I have friends who have solved more uh, problems than him and are rated quite low. So it depends on how you approach the problem, and how you take the solution, and how you try to understand what's going on behind all the intuition, and behind all the algorithms. So you have to be really a keen learner to, and you have to practice a lot. So practice a lot can you can define for yourself that what's a lot for me. So when I started, I used to practice around 3 to 4 hours a day or so. Yeah. So then, Vaishnavi. Yeah.
Yeah, so that take me to another question, like how to approach the code logic.
Yeah. So how to approach the code logic. That basically comes with the practice. At first, when I used to solve some problems, um, I would as in I was in third year. I had learned DSA, and I had learned a lot of things. And when I even used to solve simple problems, I didn't know what to use here, as in how to approach the problem. I'll give you an example. It was my I think second or third contest on CF. There was a problem. Uh, uh, there was a problem. Given a number n, you have to print two numbers. Uh, two yeah two uh, two numbers that are not prime, and their difference is n. For example, if say I have a number 1, so if n is 1, so I can just print say 9 and 8. So the difference is 1, and 9 and 8 both are not prime. Yeah. So that was the problem. So I had learned sieve, segmented sieve, and all of that, and I tried to use segmented sieve and all. So it takes a lot of code to write those things. So it took me around 1.5 hour or so to solve that. But I saw that around 4,000 people had solved that problem in under 2 minutes. So I was quite shocked that how can people solve that problem in such less time, that involves segmented sieves and all. Then later I got to know that what they did was they just printed 9 into n and 8 into n. Both of these numbers are not prime, and their difference is n. So you just had to print 9n and 8n, and that was the answer. So that was the answer to your problem, that think how to approach a problem. So there is no hard and fast rule how to approach. It comes with practice.
Yeah, yeah, sure. Yes, exactly.
Yeah, the more and more problems you solve, the better you will get. The better your approach will get.
Yes. So I think that's it for the question we got to these two questions were
Yeah,
very important, and I think these two are the main questions for the one who are just starting the
uh,
CP and how to approach it. So
yeah. I
yes,
hope that you got the answers, satisfactory answers for them.
yes, surely.
Yeah, yeah,
So I think we can end the session
yeah.
after this
So
if no one have
yeah,
any doubt. Like
yeah. If anybody has any further doubts, they can just message me on LinkedIn or anything like that. So I'll be available there too. Okay. So
yes,
yeah,
yes.
thanks a lot, Vaishnavi, and thanks a lot to you,
Yeah,
MIT,
thank you.
for having me. It was great teaching
Thank you
you
so much,
guys.
Vansh, for even joining us, and we are grateful that you could spare some of your time. And I'm sure everyone have so much to take it back and learn many new things. So, thank you so much for joining.
Yeah, thank you guys. It was nice being here. Yeah. Okay. I'll just leave.